2310 Voyager I reaches the Oort cloud. The Voyager 1 probe has been traveling through space since 1977. It reached a milestone in 2012 when it departed the heliosphere and began to interact with the interstellar medium. Its next milestone would have to wait another 300 years, however. By 2310, it has reached the inner part of the Oort cloud, a vast collection of ancient comets and icy planetesimals forming a gigantic sphere that surrounds our solar system. This begins at roughly 2,000 astronomical units, AU, extending for another 50,000 AU. Its outer edge marks the end of the Sun's gravitational dominance, beyond which lies stars like Alpha Centauri. The probe has long since been passed by faster spacecraft, which have already explored these neighboring systems. It remains drifting onward as a historical relic, taking 30,000 years to pass through the Oort cloud. 23333 AD, the Downray nuclear site becomes safe. In the mid-20th century, Downray on the north coast of Scotland became a site for experimental nuclear technology, including fast breeder reactor prototypes alongside nuclear propulsion for Navy submarines. The 178-acre facility, chosen for its remote location away from large population centers, remained in operation from 1955 until 1994. In 1977, seawater leaked into a shaft packed full of radioactive waste along with sodium and potassium. This caused a catastrophic reaction, blasting off the steel and concrete lids of the shaft and littering the area with radioactive particles. In addition, tens of thousands of fragments of radioactive fuel escaped into the sea between 1963 and 1984, believed to have washed away from the drainage of Cooling Pond. This resulted in a ban on fishing within 2 kilometers of the plant. By 2011, more than 2,300 radioactive particles had been recovered from the seafloor and 480 from the beaches. In 1998, the UK Atomic Energy Authority proposed a new timetable for decommissioning, with a cost estimated at £4.3 billion. Waste removal and the demolition of buildings began to progress over the subsequent decades. Teams working on the site used robots, including a particularly large 75-ton machine nicknamed the Reactosaurus, to dismantle parts of the reactor interior. By 2025, all legacy Magnox fuel had been retrieved, and by 2029, all radioactive waste had been removed from the shaft affected by the 1977 incident. However, much still remained to be cleaned up. The site's plutonium would not be repacked until 2060. The last building would not be removed until 2125, while the final, low-level waste would take until 2129 to dispose of. Even then, longer-term radiation effects lingered, keeping the land unsuitable for human use. In 2020, a report from the Nuclear Decommissioning Authority presented a schedule of 313 years for Downray to be fully restored. By the year 2333, this decontamination process is complete. 2460 AD. The first americium batteries are dying. In the first half of the 21st century, americium began to emerge as a potential new source of electricity for spacecraft. This human-made element was a byproduct of the decay of plutonium produced from nuclear reactors. Featured 148 neutrons and 95 protons electrons with a half-life of 432 years. The much greater mission durations provided by long-lasting space batteries enabled a new generation of deep space probes to explore the far reaches of the outer solar system. Lower launch costs, combined with ever more compact and miniaturized components, along with greater autonomy, made it possible to deploy large fleets or networks of tiny spacecraft at tremendous distances. Notable achievements in the 21st century included a partial 3D map of the Kuiper Belt, for example. Neptune and its satellites being explored in more detail, especially the Moon's surface environment, along with comprehensive studies of more distant locations such as Pluto, Makemake, Haumea, and objects in the scattered disk, including Eris and Sedna. These probes, some drifting for over 1 trillion kilometers, continued to send back data for centuries. Few even reached the Oort cloud, providing direct measurements of its composition, spatial extent, gravitational interactions, and other characteristics, as well as returning images of distant objects. By 2460, first batteries to incorporate americium are beginning to die. more than 400 years after they first began operating. The solar system is a very different place in the 25th century, however, with travel times having shrunk substantially. Much faster and more modern craft, with light speed capability, have subsequently located many of these probes, upgrading, replacing them, cannibalizing them for other uses, or returning them for historical archiving. 2550 AD. Nitrogen trifluoride emissions from 2000 AD have been naturally reabsorbed. Nitrogen trifluoride, NF3, is a colorless, odorless, man-made greenhouse gas, most frequently used by the electronics industry in the late 20th and early 21st century. It was required mainly for plasma etching, cleaning of chambers in which silicon chips were made, along with semiconductor and LCD panel manufacture. A number of other important applications were also found in the photovoltaic and chemical laser industries. Present only in trace amounts, nitrogen trifluoride was considered an environmentally preferable substitute for sulfur hexafluoride and fluorocarbon. Nevertheless, it had extremely high potential as a greenhouse gas when measured on a per-molecule basis, with 12,300 times the heat-trapping ability of CO2 over a 20-year period and 17,000 times over 100 years. Despite its low concentration, emissions were also growing extremely rapidly, from just 0.02 pt parts per trillion in 1980 to almost 1 pp by the early 2010s, 50-fold increase. Emission reduction strategies were proposed in subsequent years to limit its use and slow its contribution to global warming. The atmospheric lifetime, defined as the length of time that a molecule resides in the atmosphere before removal by chemical reaction or deposition, was calculated at 550 years. For NF3 emitted in the early 21st century, complete reabsorption by natural means would therefore take until 2550 AD. 2880 AD. The asteroid 1950 DA is passing very close to the Earth, possibly on a collision course. This kilometer-sized asteroid was first discovered in 1950. It was observed for 17 days, then lost until 2000 due to uncertainties in the orbit. In 2001, new radar and optical measurements confirmed a mean diameter of 1.1 kilometers with a very fast rotation period, 2 hours, an orbital velocity of 21.3 kilometers per second, and a dense composition of nickel-iron. It was also found to have a potentially very close approach to the Earth on the 16th March 2880. Scientists estimated a 1 in 300 chance that the asteroid would strike the planet on this date, highest probability of any known asteroid at the time. Were such an impact to occur, it would be catastrophic to civilization, given the size and velocity of 1950 DA. If landing in the ocean, coastlines would be hit by 200 feet tsunamis running inland over 4 kilometers. There would be major effects on the climate and biosphere. However, technology is so advanced by 2880 that the asteroid can easily be moved to a safe orbit if required. 3000 AD, purely biological humans are typically 7 feet tall now, with lifespans of 120 plus. For centuries now, the technological singularity has produced enormous wealth and prosperity throughout the solar system. Across-the-board improvements in healthcare, education, and living standards have led to humans evolving into a race of giants. 7 feet tall, muscular, and highly athletic, with lifespans of 120 plus. Note that this lifespan refers to purely biological, non-cyborg humans, who comprise a small minority by now. The vast majority of citizens have opted for genetic engineering and biotechnology upgrades that offer practical immortality. The pillars of creation are no longer visible from Earth. The pillars of creation were vast, towering formations of interstellar gas and dust, part of the Eagle Nebula, located around 7,000 light-years away from Earth. They became famous in the late 20th century when the Hubble Space Telescope observed them in detail for the first time, showing a trio of dramatic and eerily beautiful structures. These pillars, the tallest being 7 light-years in height, functioned as stellar nurseries for newly born stars. Later observations in the infrared part of the light spectrum revealed a nearby cloud of hot dust, believed to be a shock wave produced by a supernova. This was gradually destroying the pillars and blowing away their contents. The appearance and movement of the cloud suggested that it would have destroyed the pillars about 6,000 years previously, in 4000 BC. However, given the finite speed of light and the distance of 7,000 light-years to the pillars of creation, it would take until the year 3000 AD for this destruction to be visible from Earth. 3100 AD, humanity is becoming a Type II civilization on the Kardashev scale. The ongoing growth of AI has allowed the manipulation of matter on scales barely dreamed of before. The largest structure now being constructed in space is a Dyson sphere. This hollow shell is of such gargantuan proportions that it fully encloses the sun, capturing all of its solar energy output. Under the direction of a godlike superintelligence, vast swarms of automated, self-replicating ships are building it, using material from various asteroid fields and regions further beyond, such as the Kuiper Belt and Oort cloud. The sphere can harvest some 386 yotta-joules, YJ, per second. The interior walls have a gravitational field of 1 Gi and are made from wholly new states of matter that were unknown to science in previous centuries. These can withstand the colossal tensile forces required to maintain structural integrity. This curved, impossibly large surface, equivalent to many millions of planet Earths, is becoming a habitat for many sentient life forms, with portions being terraformed and given stable atmospheres, oceans, and landmasses. A sizable percentage of citizens are now migrating to these strange artificial worlds. This includes a diverse mix of biological humans, as well as transhumans, synthetics, clones, androids, sentient animals, and other communities. A series of additional Dyson spheres are being constructed around neighboring star systems, some even larger. Having begun its journey to the stars in the 22nd century, humanity is reaching a landmark in its exploration of space. A region nearly 1,000 light-years in radius has now been settled, or about 2% of the total length of our galaxy. 3500 AD, polar reversal of the Earth. Polar reversals have occurred many times before in Earth's history, typically every 300,000 years. The last time was around 780,000 BC. This means the planet is long overdue for such an event. From 1900 onwards, the intensity of Earth's magnetic field was known to be declining by 6% each century. By 3500, the poles are beginning to completely reverse. Charged particles from the sun affect satellites and other near-Earth vessels, which lack adequate protection. However, plants and animals on Earth are unaffected. During the reversal, solar wind induces a sufficient magnetic field in the ionosphere, temporarily shielding the surface in the absence of the normal magnetic field. The grand unification energy is witnessed. First particle accelerators were small, terrestrial-based devices. In the early 21st century, they resulted in energies of only a few tera-electron volts. By the middle of the fourth millennium, however, an accelerator covering the entire perimeter of our solar system has been built. This becomes the single largest experiment in history, powerful enough to accelerate particles to a state known as the grand unification energy, allowing the very earliest moments of the universe to be simulated. The electromagnetic, weak and strong nuclear force, three of the four fundamental forces, are viewed for the first time at precisely the same strength, becoming effectively different aspects of a single force. Quarks and electrons, too, become the same, achieving another unification. 3900 AD. The Sun has exited the local interstellar cloud. The local interstellar cloud, LAC, is a region of the interstellar medium, about 30 light-years across, through which our Sun has been moving. The LAC is primarily composed of ionized hydrogen, H2, and neutral hydrogen, Hi, along with traces of helium and other elements. The Sun first entered the LAC around the 8th millennium BC. Solar winds carving out a vast bubble, marking the outer edges of our solar system. As it passed through at 26 kilometers per second, a long teardrop-shaped heliotail followed in the Sun's wake. During the modern era, it began entering a transition zone between the LIC and neighboring G clouds. By 3900 AD, our Sun has completely exited the LIC and is entering the G clouds. While the LIC's density is 300,000 atoms per cubic meter, the G clouds are significantly more diffuse, at less than 100,000 atoms per cubic meter. However, the G clouds are much larger in spatial extent, forming a region several hundred light-years across. 4000 AD. Computer science is reaching its ultimate potential. The biological and technological descendants of humanity are attaining the perfection of computer science. Millennia of both theoretical and practical testing means that all of the knowledge required for every permutation of hardware and software is now available. New applications can be instantly created in real time and with zero errors. From this point onwards, computer science becomes obsolete as a field of study. The only unknowns left for researchers to discover will be in other areas of science. 000 AD. The Crypt of Civilization time capsule is opened. The Crypt of Civilization is the oldest millennial time capsule in the world. Durated between 1937 and 1940, it had a volume of 2,000 cubic feet, 57 m3s, and contained thousands of objects, also making it the largest room of its kind at that time. Professor Thornwell Jacobs, the initiator of the project, felt inspired by the opening of the Egyptian pyramids and wanted to create a repository of everyday objects from the 1930s, alongside a record of human knowledge. He calculated that 6,177 years had passed since the start of the Egyptian calendar, and proposed the creation of a modern archive to be opened in 8113 AD. Following another 6,177 years, architects took what had been a swimming pool and modified it to create an impenetrable airtight chamber of 6.1 by 3 by 3 meters, 20 by 10 by 10 feet, sitting on a bedrock floor and with a 7 feet 2.1 meters thick stone roof. They lined each wall with plates of enamel, secured in place with pitch. A stainless steel doorway was welded permanently closed after the oxygen had been removed and replaced with inert nitrogen. Notable items placed within the room included microfilm copies of important documents, books, photographs, recordings of music and speeches, examples of technology and scientific instruments, artistic works, and various everyday objects such as clothing, tools, and household items. This collection aimed to provide future generations with a comprehensive snapshot of life and culture during the time of its sealing. The crypt inspired the creation of many other time capsules around the world. Journalist and historian Frank G. Menke asked movie star and singer Bing Crosby to be master of ceremonies at the eventual reopening. Crosby responded to this by saying he would be glad to do that, as long as his filming schedule at the time would allow it. Centuries and millennia passed, with humanity and the world going through profound changes. Throughout this time, the crypt remained safely sealed and preserved in exactly the same condition as the day its creators left it. 28th May, 1940. Today is now equivalent to the year 8113, although the Gregorian calendar has long since been abandoned in favor of a new system. Advanced life forms, descended from the hybrid human-AI mergers of past millennia, have been instructed to open a room within the archived remains of Oglethorpe University, located in a region that used to be known as Georgia, United States. No cutting tools or machinery of any kind are required. These beings can simply direct their gaze at the large steel door, gently willing its atoms to move apart with an invisible force. The objects inside are primitive, rousing curiosity and a deep sense of the passage of time. Each artifact is made to levitate through the air, so it can be removed in perfect condition and taken away for analysis. Ancient English language, which fell out of use during the third millennium, is deciphered and the room's contents are placed in a more permanent archive, alongside objects from many other time capsules of the past. These items are now viewable by visitors from around the galaxy. 8703D. The return of Comet Neowise. Comet Neowise first came to the world's attention in the year 2020 when astronomers using the Wide Field Infrared Survey Explorer WISE space telescope observed its approach towards the inner solar system. 3 months after its official discovery, the object had become visible to the naked eye as one of the brightest comets in the northern hemisphere since Hale-Bopp in 1997. Planetary Science Institute in Arizona, USA, confirmed a sodium tail observed only in very bright comets. It had also developed a second tail. From the infrared signature, astronomers estimated the diameter of the comet nucleus to be approximately 5 kilometers, 3 miles. Neowise made its closest approach to Earth on 23 July 2020 at a distance of 0.69 AU, 103 million kilometers or 64 million mi, while located in the constellation of Ursa Major. At this point, its trajectory placed it above the plane of the ecliptic, flat, imaginary disk on which planets and the Sun sit. Comet passed over the orbits of Mercury, Venus, and Earth before dropping down below the plane of the ecliptic between Mars and Jupiter. A long-period comet with a highly eccentric orbit, its return period had been calculated at 6,683 years, meaning the next perihelion would not occur until the year 8703. 19,500 AD, Betelgeuse is colliding with a dusty wall. Betelgeuse is the nearest red supergiant star to Earth. It can be seen with the naked eye in the northern hemisphere winter night sky as the orange-red star above and to the left of Orion's famous three-star belt. Roughly 1,000 times the diameter and 100,000 times the brightness of the Sun, Betelgeuse is on its way to becoming a supernova, having already swelled in size and shed a significant fraction of its outer layers. The star's winds are crashing against the surrounding interstellar medium, producing a curved bow shock as the star moves through space at 30 kilometers per second. A series of broken, dusty arcs ahead of the star's direction of motion testify to a turbulent history of mass loss. In the early 21st century, the Herschel Space Observatory found a mysterious wall-like structure in far infrared. It was seen further away from the star, beyond the dusty arcs, its linear shape indicating that it was completely separate from and unrelated to Betelgeuse. It was, however, being illuminated by the supergiant. Astronomers of the time believed it was either a linear filament linked to the galaxy's magnetic field or the edge of a nearby interstellar cloud. In 7000 AD, a collision occurs between the wall and the bow shock zone. This is followed by a collision between the wall and Betelgeuse itself, some 12,500 years later. 22,000 AD, the Chernobyl disaster site becomes fully safe. The Chernobyl explosion, which occurred in 1986, was the worst nuclear accident in history, affecting tens of thousands of square kilometers of land. Radiation at the center of the former disaster zone has decayed to negligible levels by now. 27,000 AD. The Arecibo message arrives at M13. In 1974, astronomers at the Arecibo Observatory in Puerto Rico beamed an interstellar radio message towards Messier 13, a globular cluster in the constellation of Hercules. It became the most powerful broadcast ever deliberately sent into deep space, and formed part of the ceremonies held to mark a major upgrade of the radio telescope. The broadcast was particularly powerful because it used Arecibo's megawatt transmitter, attached to its 305-meter antenna. The latter concentrated the transmitter energy by beaming it towards a very small patch of sky, potentially making it detectable to a receiving antenna operated by extraterrestrials many thousands of light years away. The Arecibo message carried basic information about humanity and Earth. The binary transmission, designed to be easily decoded by intelligent aliens, contained a list of numbers, DNA elements, nucleotides, a double helix, the human form, planets of our solar system, and a graphic representing the Arecibo radio telescope and indicating its diameter. In total, these 1,679 binary digits amounted to 210 bytes, 0.21 kbytes, of data. Messier 13, M13, is one of about 160 globular clusters, dense, spherical collections of stars that resemble miniature galaxies, orbiting the Milky Way. Approximately 145 light-years in diameter, M13 contains several hundred thousand stars. The cluster is located around 25,000 light-years away, meaning a radio transmission sent from Earth in the late 20th century will arrive by the year 27,000 AD. By now, M13 is no longer in precisely the same location as in 1974 because of the cluster's orbit around the Milky Way center. Even so, the proper motion of M13 is small, so the message can still arrive near the center of the cluster. 30,000 AD. First wave of sublight vessels has reached the galactic core. The Milky Way's core region is located 27 to 28,000 light-years from Earth. At its very center lies the largest black hole in the galaxy, a supermassive black hole known as Sagittarius A. Having traveled for many millennia, first wave of sublight spacecraft has now arrived in its vicinity. These ships contain no physical human crew, being entirely computerized and automated. Numbering in the trillions, they have self-replicated along the way, using local stellar and planetary material gathered en route. Systems encountered during this epic voyage have become seeded with computational substrates and saturated with artificial intelligence. Individual planets and moons becoming like brain cells in a gigantic artificial organism. It is almost as though the galaxy itself is waking up and achieving self-awareness. There is no competition or battle to claim ownership of the core. Wars, greed, and archaic concepts of nationality have long since disappeared, with sentient beings now united under a common heritage. In addition to the black hole are dense concentrations of ancient, metal-rich stars, in places separated by just a few light weeks or light days. These provide an enormous pool of resources for the approaching fleet. Gamma radiation is very high in this region, making it harder for biological life to survive than in most other parts of the galaxy. Were an observer able to stand on a planet near the core, the sky above them would appear as a dazzling display of light and color. Having reached the galactic center, the AI descendants of humanity begin to exploit the vast amounts of rotational energy from Sagittarius A*, by far the greatest source of power in all history, and a major milestone towards becoming a Type 3 civilization on the Kardashev scale. Efforts are now underway to explore the far side of the galaxy and the mysteries that lie beyond. Dozens of globular clusters have also been reached by now. 35,000 AD, Ross 248 becomes the closest star to our Sun. Alpha Centauri was previously the closest star. Ross 248 is a red dwarf, with approximately 12% of the Sun's mass and 16% of the Sun's radius, but only 0.2% of its luminosity. However, it is also a flare star that periodically undergoes sudden, dramatic increases in brightness for a few minutes. In 2010, Ross 248 was 10.3 light-years from Earth, with a radial velocity of -81 kilometers per second. By 35,000 AD, it is closer than Alpha Centauri. It reaches its closest point in 38,000 AD, moving to within 3.1 light-years, before receding again, becoming further from the Sun than Alpha Centauri in 44,000 AD. 69,163 AD, transit of Mercury and Venus. Transit occurs when a planet moves between a star and an observer. Such events can be witnessed from Earth when Mercury or Venus pass in front of the Sun. Similarly, the solar system's inner three planets, Mercury, Venus, and Earth, can be viewed passing in front of the Sun by an observer on Mars. Transits are much rarer than eclipses of the Sun by the Moon. On average, 13 transits of Mercury take place each century. Transits of Venus are even rarer and occur in pairs separated by 8 years, repeating every century or so, such as the events of 2004 and 2012, followed by 2117 and 2125. Historically, transits provided astronomers with important mathematical and scientific information. For instance, the 1639 transit of Venus yielded estimates of both the size of Venus and the distance between the Sun and Earth, while the predicted transits of 1761 and 1769 further improved this accuracy via the use of the parallax principle. Scientists used a 2012 transit of Venus to refine their techniques for discovering exoplanets. Meanwhile, colonists on Mars witnessed a transit of Earth in 2084. Even rarer still are transits involving 2 or more planets in the observer's field of view. A simultaneous transit of both Mercury and Venus, from the perspective of a viewer on Earth, last occurred on the 22nd September 373,173 BC, during the Lower Paleolithic, before anatomically modern humans had evolved. The next occurrence is 26th July 69,163 AD. This double transit lasts for about 30 minutes. It does not occur again until 29th March 24,508 AD. 100,000 AD. The red hypergiant star, VY Canis Majoris, has exploded by now, producing one of the largest supernovas the galaxy has ever seen. VY Canis Majoris, at between 1,800 and 2,100 times bigger than our Sun, 8.4 to 9.8 AL, 2.7 billion kilometers or 1.7 billion miles in radius, is the largest known star in the Milky Way and also one of the brightest known. It is located around 4,900 light-years from Earth, in the constellation Canis Major. It was discovered to be very unstable, throwing off much of its mass into the surrounding nebula. By 100,000, it has finally exploded, creating a supernova bright enough to be seen during daylight hours on Earth.